Now let us see how to execute the program in ISC design suite. Double click on ISC design suite. Okay, a window will be opened. If you have any previous opened projects, go to file, close all the projects, then go to file, new project, then give the name, click on next. Next you have to check for family, the family has to be Spartan 3, then click on next again, finish. Now after giving the project name, go to hierarchy window. Here on XCS, right click, new source, select Verilog module, give the file name, click on next. So now we have to give the mention which are all my inputs and outputs. You can observe here we have A, B, C as input and Y as output. Mention them: A, B, C and Y. Okay. Now scroll down this, change it to output, click on next, finish. So now we have to write the program, that is wire S1 OR gate with output S1 and input AB, and AND gate with output Y and input S1 and C. Next, after this, go to file, save. After saving the program, you have to run to check whether, click on synthesis. If you get like this, it means you have an error. Go to error window, read the error. It is expecting semicolon at line 32. So that is here, you have left with a semicolon. Type Ctrl S, run the program. Okay, if you get this green tick, then there is no error in the program. After writing the program, we need to write the test bench. Right click on .v file, new source, select VHDL test bench, give the name for the test bench, click on next, next, finish. It will take some amount of time to create a test bench. After creating a test bench, select simulation here, then you have to select UUT file, click on behavioral check syntax, then click on simulate behavior. Now we will get a waveform. Here you can observe we are getting input as Z and output as X. Because we have not specified the inputs and outputs, we need to specify the inputs here. We have to right click on A, go to force clock. Okay, after this, give leading edge as 0, trailing edge as 1, then cancel time as 8 picoseconds for 3 inputs, then time period as 8. Click on apply. Then change this A to next input, that is B, shift B. Keep everything same, just change the period, apply. Then change the input to C, change the period to 2, apply. Okay, now click on run. Now you can observe the output here. Okay, for 0 0 combinations, for 0 0 combination we have 0 as our output. You can observe the same in the truth table. Okay, for 0 0 combination the output is 0. For 0 1 1 combination we have output as 1. For 0 1 1 combination, we have output as 1. Now let us execute the data flow modeling. Here the procedure followed is same, but the writing procedure of the program will only be the different way. Here we need to use assign statement. Now let us see how to execute this. Double click on IEC design suite, file, close the project, or you can edit the same. Just go to implementation, double click on the program that you have written, change the program, save it. After saving, next all the procedure has to be followed in a similar way. We need to synthesize the written program. After getting this green tick, after getting this green tick, we need to right click on this circuit, new source. We need to create a test bench for each and every modeling separately. Now we are creating a test bench for data flow modeling. Create, click on next, 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 finish. Then go to simulation. We have created another text bench here, the second one. Select it, check its behavioral syntax, then simulate this behavioral model. You'll get a waveform with an unknown value. Now we have to give the values for input. Right click on A, force clock, leading edge 0, trailing edge 1, off time take it as 8 picoseconds, period as 8, apply. Now select B, everything will be same, only the period will be changed. For apply, then select C, change the period to 2, apply, OK. So now run the program. You can observe you will get same waveform, because we have written we have considered the same circuit, but we have written the program in a different way. So similarly we can execute behavioral model. Now let us see how to execute this behavioral model. The one thing that has to be changed is output has to be declared. Here the output has to be declared with a keyword register. Then this part of program has to be executed. Now go to implementation again, click on your Verilog program, double click. Now change this assign statement to behavioral modeling. Here the output has to be declared with a register keyword. These are the changes to be made. After this, again save this, simulate it. Okay, we can observe we got a warning. Let us see what is the warning. Here they are saying that input C is never used. In case we have used only 2 inputs, change it to ABC, then again synthesize that. If you require, you can run implement design too. Okay. Now go to simulation. Before going that, right click on B, new source. We need to create a Verilog test bench for behavioral modeling. Then click on next, next, finish. The test bench has been created. Go to simulation. The third test bench what we have created, click on that, check for syntax, then simulate. Now you can observe the output. Right click on variable, give force clock, leading edge 0, trailing edge 1, timing offset as 8 picoseconds, then period as 8, apply, take B, change period to 4, apply. Now take input as C, change period to 2, apply, OK. Run the program, you will get the waveform. This is how to execute the programs using Xilinx software.